right, now you can hear me. Thanks for reminding me. I forgot my phone was on mute. And welcome everybody coming on to Zoom today, and also welcome everybody on Facebook Live for our March Live with Nassim session. We're always grateful that everybody comes to this. We have over 100 people, 108 people right now in our Zoom session. And this is a chance to get some time with Nassim, talk about unified physics, talk about science, ask some questions, and get a deeper understanding about this really important topic. It's very important for our times right now to come to this understanding and bring this paradigm shift of the understanding of the science and the unification of science and the unification of our worldview in this context. It's so important at this time. So we're always grateful, Nassim, to have a chance to talk with you. And for those who are coming on right now, welcome on Zoom. This is a chance for you to post also your questions for Nassim. And there's a Q&A button down at the bottom of the screen where you can click that to post a question. Just post one, maybe two at most, if you would. We always have more than we could ever get to. You can also vote questions up with the thumbs up. And we do look at that for a while and see what's popular, and then we might choose some other questions along the way as well. And then just say hello in the chat in Zoom here, as many of you are already, and let us know where you're coming in from. We always love to see, there's always people from all over the world, and I'm so grateful for that. And be sure to change your chat setting, because this is something that doesn't happen automatically in Zoom. Change your chat setting to say panelists and attendees rather than just panelists, so that everybody can see your chat. And I'll put some reminders in the chat as we go. So be sure to change to panelists and attendees. And I see some questions coming in, and Nassim, I want to welcome you again to a Live with Nassim session. You've been doing this for a while. I think you might be muted still, so unmute yourself if you are muted. And Hi. There we go.
Good to be there.
Brother. Welcome.
Hey, good to be here again. Same channel to plug into the universal flow and be with everybody.
Indeed.
Yeah. How you been?
I've been well. I've been feeling really, really good and healthy and creative, and pursuing some interesting projects and future things coming up. Researching kind of what's happening in the realm of alternative systems that will help humanity to go more towards the direction of sovereignty and real data, privacy control, things like that, which I think are important aspects of what we want to move towards in our systems development. So learning some interesting things about that. Energy independence. Yeah, that too. Hey, for some reason your audio is not so clear now. I thought it was clear when we started, but it's kind of phasing in and out a little bit when you talk. So something's...
Maybe it's on your side. It seems you have a little bit of slow internet.
Yeah. When we're not chatting back and forth, then it's okay. So we'll not have so much of a conversation, but yeah, things are good for me, and energy independence is going to be one of those important things. But why don't you just say hi and
yeah, I mean,
give a little intro.
The energy independence meaning independent of a region, right? Meaning that the energy is available everywhere in equal amount, right? So that
right,
and that really is kind of like the keystone of the transformation required in all of our organizations and so on, because it removes one of the biggest stressors in terms of resources on the planet, which is, you know, accessibility to energy. And that's really like the big difference between an advanced civilization that has found ways to extract energy literally from the foundation of creation, you know, and utilize it, which returns back to the foundation of creation as you utilize it, as it's radiated in terms of angular momentum, or, you know, whatever heat, whatever you're producing with the energy, it's going back. And so basically you're just in the flow of the universe. It's like if you had a hydroelectric dam where the water is the natural fluid of space-time, right? So the energy potential is always there. There's always water in the lake, and it's always falling through your turbine, through your device, right? Which could be a turbine, but it might be a little more complex turbine, you know, it might be a plasma turbine or something, right?
Yeah.
Just saying, just like that. And and then you could have energy anywhere you are, because there's space-time everywhere you are. And that means that you could be off planet and have as much energy as you need to do anything you want. And all of a sudden, you know, like, society changes at a very fundamental level. And that change has financial and, you know, all kinds of societal impact.
I was going to ask you, you know, that changes the entire concept of what an economy is, when the true abundant nature of the universe, which is, like you said, there's energy available always, anywhere, all the time. That changes even the notion of what an economy is, which has generally been based on resource availability or scarcity and supply and demand and all that.
Right. Well, no, it changes system from scarcity-based system, that is, the value of something is at, you know, as little as there is, you know, smaller it is, larger the value, to another approach, which is that has to do with more, maybe you could even think like creative approach, that is, it's what you can create with the resources, because you basically have access to almost an infinite amount of resources. I mean, if you can travel the solar system easily, you can have access to all the ores and all the water you want. Like, you know, I mean, it's not the scarcity of something. Like, you can have the, you know, gold from all the asteroids, you know, and the asteroid belts, you know, there's, you know, so it's not so much how little there is of something, it's what you're doing with it, right?
Yeah.
That has value, you know.
With value creation in the innovation aspect.
Exactly. And your capacity to use it to, you know, explore the universe and transform your awareness, and, you know, explore. And when I mean explore the universe, I mean it in terms literally of going around the universe, but as well explore the universe on all different ways. You know, the meaning, you know, you could think of exploring the universe of artistic expression, when when you have
Right.
almost infinite amount of energy and infinite amount of resources to do an art form, right? What it looks a little bit different, right? It could be,
Mm.
could be the size of a spaceship, you know,
Yeah.
um, floating around the sun somewhere in the galaxy, Um,
Mm.
so
What's your sense of just in the it's sort of in this phase of transition we're in on our planet here? There's an obvious discrepancy in inequality of energy availability around the world, and if that were to become equalized, meaning through these technologies, anybody anywhere could have all the energy that's needed without causing stress on the resources of the planet the way it is right now, both
right.
in terms of utilizing resources and the pollution that they cause. Those things eliminated. What would
all of a sudden,
how would that?
Yeah, all of a sudden, like places that you could say, let's give a direct example, like you could greenify a desert
Mm.
and not have to worry about like how you're gonna get that much power to for the irrigation, for everything, like how you're gonna displace the water, and like you can you can do all this without having to worry about the energetic cost and the environmental impact of producing the power, right? Or the infrastructure becomes much lighter as well because it's localized, the source. So you can imagine that you can desalinate the water from the ocean, for instance, in regions where there's not enough potable water, and you don't have the problem of having to find the power to do this. You have it available on site, so you can do things that are very, very productive for the sustainability of regions that currently are having major issues, and it equalizes the capacity of all the nations to be able to be sustainable, and bypass, certainly for countries that of the third world that are coming into the technological developments and transformation in their culture, to bypass the carbon emission stage, although it's a little late for that, but I mean it's
we can obsolete it though.
Yeah, if we can remove that step, and go straight to vacuum energy, then we can really make a huge impact on the environmental challenges that are currently present, and not just environmental challenge, but as well the survival, literally, of the species challenge, which is fairly highly threatened at this point, in terms of
really
and our capacity to produce energy, and how to, how we transport things, and how we vehicle ourselves. I mean, all this has to, and it has to change pretty fast. And solar panels and windmills are not going to do the job. They're just not. And
plus, they're very environmentally damaging as well in their production.
Very much so.
Highly and the efficiency is way too low.
Yes.
And the other thing is that this will stabilize our, right now the energy grid is so fragile, both in terms of local weather events like we saw in Texas recently, as well as solar events that could just knock grids out in a moment. That would also be eliminated. So we would stabilize our core foundational experience without to eliminate those threats, which would be a huge thing to do.
And our capacity to survive in an harmonious relationship and thrive with the universe.
Yeah.
So
it's really such a key.
Yeah, it's a key to the transformation of humanity, and it needs to be supported appropriately and investigated and moved towards.
And these technologies exist, is my understanding already. They have for quite a while, and of course they've been suppressed, as I think most everybody here probably has some exposure to. You feel still, I know we've talked in the past, you feel still that that some of that suppression and control is lessening, or are we still kind of a fine line with all that?
Well, I like to think of it as the evolution of consciousness that's required for the event to go, right? So, think of it as, in physics, we would call it back torque, or, impedance, and the impedance is what polishes the diamond. So, it's a required part of creation. And so it's just has to do with our global decision to, to make a difference and to make this transformation happen. And, that is a time sensitive thing, because natural systems are very cyclical, and they have very clear, constructive and destructive patterns. And if you're on the constructive side of a pattern, you want to get out of the way of the destructive part of the cycle. And so you have to be sustainable, and you have to be mobile. You can't just be stuck to the surface of a planet. A planet will eventually lose its atmosphere, transform its temperature gradient, and there's many things that will stop a biological evolution on the surface of a planet. And the fact that we're still here, I mean, the power grid is one thing. One good sun flare directed towards the Earth would wipe out most of the power grid of that side of the Earth very quickly if it was head on. It's very easy to do. I mean, it's happened already a few times in certain regions. At one point, Eastern Canada, I remember when I was a kid, lost power. Almost all of Ontario and Quebec lost power because of a sun flare. And it blew the, transformer cans on all the poles, and replacing those.
Charge surge.
Yeah, it was lucky it was in the summer, because a lot of people were been. So, so the fact that we're still here talking about it is a miracle, and but I think we shouldn't push our luck. We should, get our shit together, and kind of go with the universe a little better. And I think the first part of all of that is really a unification of races and unification of minds on the planet, because we have everything we need to get the job done. If we unify,
we sure do.
then it's the first step to transforming, the whole thing with beneficial results for everything, not just for the individuals, for corporations, for, it's good for everybody, it's becoming abundant as a whole, as a society is a really good thing. It's
very liberating.
It's not to the detriment of anybody. And so it's really a critical moment in the evolution of a society. You can see it clearly that at one point they either unify and go to the next level or self-destruct because of, too much chaotic interactions and
didn't get their shit together in time.
Right.
That way.
Yeah,
basically.
that way. Yeah.
Yeah.
And there was a sun flare and the atmosphere blew, and it's like, it's
bummer.
Right? Bummer. Oh, it looks like Mars, right?
Yeah, right, exactly. Hey, there's a question we can start with here that ties into what you were just talking about. That's popular in the list here.
A few million years later, some other civilization is sending a probe on your planet,
Yeah.
rolling around, looking at things, going, wow, wonder what happened to those guys.
all too true. Yes, and it's called perseverance. Literally. Well, that's a great summation of kind of the threshold we're at, the necessity of embracing the opportunity we have, and what that opportunity looks like and what it would look like once we embrace it.
Yeah.
So you want to go into some questions?
Yeah, that sounds good.
Yeah, so this one was related to what you're just talking about in terms of the shift in our consciousness, from David Knox saying, can we as individuals learn to sense, cultivate, and leverage our connection to the field, space memory, to make changes in our lives and to accelerate the expansion of human consciousness and subsequent healing of our planet? If so, how do we do that? And I'm going to invite participants on, and if you want to come on, you can open your video up and your audio. Otherwise, if you don't want to come on, you can just leave those off, as usual. So go ahead, Nassim.
Yeah, so can you read the beginning of the question? Is it the first one?
Yeah, it's the second one then. Second one, because it was related to what you're just talking about. Can we as individuals learn to sense, cultivate, and leverage our connection to the field, the space memory, to make changes in our lives?
I get it. Yeah. So, well, yes. The first thing to do that, to improve it, is to realize that that's already happening, right? It's the main thing. It's like your connection to the field is already happening. Hey, David, nice to meet you.
Hey, guys.
Hey,
Where
David.
are you at, bro?
Good to see you again.
Hey.
Where are you at?
I'm in Portland, Oregon.
Oh, cool.
Yeah, I was down in Santa Cruz with you at the end summer 2019. I also went to Peru, and I've been trying to work through cosmometry since August 2019.
Oh, nice.
it's a
All right.
That's cool.
Well,
But,
keep going, keep going.
right? But this question, I mean, this is the central preoccupation of my life. And it occurred to me after, Nassim, after listening to you on YouTube for years, that since we're a holographic fractal representation of the universe, that its nature is our nature, and what we can observe is that it's evolutionary. And so that seems to be the thing. Like, all these spirit heads are out here trying to manifest their perfect lives, right? They're trying to use the secret or whatever. And, you know, it's hit and miss. And it occurred to me that the thing that's missing is that probably, maybe, the universe wants us to evolve first. Like, that's the first thing that we have to do. And the rest of it is secondary to that. And so I've been playing with this idea, but it all boils down to the idea that if we evolve, that's probably the thing that will help us to live a better life and to heal the world, because that's really the only lever we have to pull, right? Is ourselves.
Exactly.
But all of this boils down to our connection with the field. And so, you know, to me, it comes down to how do we cultivate that?
Yeah, that's what I was saying. It's the first step is to realize that you're already connected to the field. So that's, you know, so I mean, not just in a conceptual way, to experience this connection with the field, right? So you have to feel it. So it's like something that you were not aware of, that you have to become aware of. You know, that like you're interacting with the field. And how does that feel? Like, meaning, because people might say, oh, well, I could think of a field outside of me, right? Because that's what people visualize typically. But when I'm talking, connecting with the field, I'm meaning, wait, the field that you're connecting to is making up all of your atoms right now. So that's the field right there, right? So it's not just outside you, like the space, but it's like all of your atoms and all the space in your atoms, which is a lot. It's a lot of energy in terms of Planck fluctuation. You know, it's insane, the amount of energy, right? It's beyond anything you can. It's hard to visualize, because in the centimeter cube of space, there's like 10 to the 93 grams of you know, of energy mass. So it's, and 1093 is 39 orders of magnitude larger than the mass of the universe. So, you know, and you're made out of way more than 1 centimeter of cube. And so if you just consider that, right? But that's just the potential energy. I mean, and what I mean by just, I gotta make it a little more precise. Like, it's eventually the source of the kinetic energy, which you call you, right? And I want to clarify what I mean by that, because I don't mean it in a standard way, because the standard way doesn't have the source of inertia in it. So, you know, here I'm talking about the potential being the source of inertia, right? Just so we're clear when I'm describing the kinetic function, which you can measure, right? It's called your body burning at almost 100 Fahrenheit, you know, 24/7, right? That kinetic energy, yeah, of the organization of space in that region, right? That's the field I'm talking about, becoming aware of, being connected to, right? So that you remove the separation between what you're calling matter and space. Matter is space organized in a certain way. Matter is a field, right, organized in a certain way in space, and you call that you, right? So as soon as you become aware of this, then all of a sudden it's like, oh, okay, and I can modify that field, because you could think of that field as a field of information, and you are gathering and expressing information in that field. So you're informing the field, right? And the process of evolution is to actually become aware of that and become an informant of the field that has a positive effect on the information, on the coherence of the field around me, right? So that it's not chaotic in the field around me, it's coherent in the field around me. Because I have made a coherent field within me. So it has an impact. It's called frame dragging. And I could actually give you the equation for that, right? So not just the standard equation for frame dragging, which, is known in Einstein field equation, but actually the relationship of that equation to the energy that makes up your atoms. So the whole, thing that that we call so evolution is really just your capacity to create coherent behaviors around you, and hopefully that becomes collective, right? So then there's collective coherent behaviors, so the relationship of you with the rest of the world and how you interact with it and how much these connections become coherent, right? And then the collective of the whole planet being a coherent, and then that expanding to the solar system and eventually the galaxy and so on, right? With more and more interactions with the universe. Does that make sense? Wait, you're muted. Oh, you're
Yeah,
still
yeah.
There you go.
Yeah, it does. And I think so I think that we're special as human beings in terms of biological life because because we have the awareness to realize that we're made up, that our matter is organized by this field. And that if we can become aware of that, then that means that we can start to resonate with that field.
You could almost argue that animals, you could argue that animals are extremely aware that they are interacting with that field. But that the humans kind of got confused for a while,
So I think that animals just don't have their intellect to get in the way, and they just live. They couldn't articulate that they're part of that field, but they're just connected, and that's all they are.
Yeah.
Because that's how they live. That their instinct is fed by the information from the field, and that's how they live.
Right. You could think of it as the field organizing systems that evolves, right? Because the field is evolving, and the evolution needs it's like brick and mortar, right? You need all the environment, you need the trees, you need the animals, you need everything so that it can evolve, that can become more and more complex, more and more advanced, that it can, build the more and more things. And then, eventually at the very point, hopefully, it blooms into now it can travel through the solar system. Now it can travel through the galaxy. Now it can travel through the intergalactic, inter-universe, whatever, right? So and you can actually literally match the I used to talk about this in my conferences in the 90s, that you have a direct correlation between evolution and your capacity to travel in space. Meaning cavemen couldn't go very far, right? And didn't have much awareness of the environment far from its five senses, which were limited in terms of his capacity to, move on the geodesic of space-time, and and go and visit places and all this. And so then you see an evolution as that becomes more and more available and easier for people to like go around, and then more and more evolution. Now, you know, you get on a plane, you don't think twice, you go to Australia and, you know, experience a completely different culture in the, you know, in the backcountry of Australia with Aboriginals in a few hours, right? So this is something that transforms. So now imagine transforming that capacity of exploration and transformation and awareness to like making it easy for anybody to go and orbit Jupiter for the weekend and experience the solar system. Like, what would that do to your consciousness, right? Like every astronaut that's been out in space and looked back at the Earth, most of them actually, you know, every one of them that I talk to and the interviews I've seen, they always say the sense of unity is obvious, right? They look at the Earth and they see the Earth and all the people on it as one thing, and you know, it looks independent from the surface, but very interconnected, like just even by weather systems. And you see the weather systems going around. It doesn't have, you know, countries and lines where it cannot go, and, you know, it just does its thing. And, you know, a hurricane here produce an effect there, and the current here produce another effect here. And, you know, the water here is moving over there. And, you know, it's one thing that's uniform. So that right away transform your awareness, and what is your relationship to the universe when you're orbiting Jupiter is vastly different than what it is if you're stuck on the surface, you know, in a city or on a farm, you know. And so it's just an evolution of awareness and information of the field, and always seeks larger surfaces because it's holographic. So it seeks larger surfaces. So meaning that it duplicates, right? Gives more and more surfaces. It fractalizes. It gives more and more, you know, points of information from more and more perspective, more and more, you know, coordinates in space-time in the field, right? Like this, the field that you're made of, which is this organization of matter and all this, that's like it's duplicating itself, you know, with the resources of the environment, like the atoms that are present that came out of the sun and made a planet. And, you know, like it's using everything it's got to, you know, it organizes in more and more complex ways. And eventually, you know, it gets a level of complexity and feedback, right? That goes, oh, wow, what is this universe I emerged from, right? You know, and what is this consciousness that animates me, right? And
so
all
then,
of us, it unifies.
So then we
And
would
we're going to have to wrap this one up pretty soon here now and get on to some other questions. But do you want to make a final comment?
Yeah, I was just going to say, so as humans, we can do two things. We can go inside, of course, in meditation. We can go out in travel internationally, especially. But like, we're now little creator gods because we're aware of this. And we can start to mold the field around us. We can start to play with the field around us because it's what's organizing energy and systems and everything else. So we can actually do that without lifting a finger, theoretically.
Correct. And we can do that technologically to produce power and power civilization and everything, you know. When you understand that everything is made out of that field, then you understand how to, that means you understand the geometry of the field, how it functions, you know, what is an electric field, what is a charge, what is mass, you know, all these things, gravity, electromagnetism. So now you can you know, play with the field instead of try to fight it. Right?
Awesome. Yeah.
Let's do that.
Thank you, guys.
David, thanks so much for your question and for being here always. We appreciate that. Take care.
Bye.
Yeah, that was a good one.
Yeah.
So this next one at the top of the list here is from Beth Hazard, asking, when looking at the structure of the tetrahelix, you can see a triple helix because of the tetrahedral geometry.
Yeah.
Does this represent a third strand of DNA? What are the implications of a third strand? DNA can be considered fractal antenna. Could a third strand set us up for telepathic communication with remote parts of the universe or multiverse?
I would argue that that's already available on the two-strand DNA. Three-strand DNA, you know, is already present. Like, it was found in cellular structures and published in the last few years. So it was found already twice, I believe, by two different labs. But it might be more at this point. Hi, nice to meet you.
Nice to meet you.
How do you pronounce your name?
Beth Hazard. Like.
Oh, Beth. Okay.
Yeah, Beth. Yeah.
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 Okay.
That,
Nice to meet you. Where are you at?
I'm in Portland too.
Oh, wow.
Lots of Portland here.
Portland,
Yeah.
chiming in.
Totally.
Yeah, you got a dinosaur over your head.
I do. This is like my kids put that up there.
Yeah.
Yeah.
How old are they?
They are almost 5 and almost 10. 2 boys.
Oh.
Yeah.
Boys, I got 2 boys too.
Awesome.
Yeah.
How old are your boys?
10 and 15.
Oh, so like, yeah, that's interesting. Yeah.
So I have a teenager at home. So now I'm really learning about you know, different way of being in relationship to my child. So it's very good learning. Yeah, it's very good learning opportunity. We'll call
Yes.
it. Can you ask the question again?
Well, so what I was asking about is like how, if this, I mean, I've looked into this and seen that, like, yes, this triple helix does exist, like as a DNA triple helix. But, you know, when we're doing, like, say you're working with like using the arc crystal structured water, like, is that, and that water is interacting with our DNA, obviously, like, are we creating some type of, like, maybe activation or like stimulating that third strand? Is there some kind of like further function? Like, what is it going to do for us?
Yeah, so you know, that's the, I mean, it's a deeper question that has to do with the structure of DNA and you know, the amino acid relationships and all this stuff, and so and the codons, and so we could go down the rabbit hole, but let's just keep it that the water molecule is what is the source of the modulation of DNA that organizes the amino acids and so on. So it really doesn't, like the sugars, it doesn't, the water molecule is where the information flow, if you'd like, from the structure of space-time is coming from the hydrogen oxygen atoms, and the relationship between them. And you can think of these relationships, you know, okay, you know, bond angles and so on, in terms of forces, but in a non-classical approach to forces, meaning that you can think of forces instead of some kind of particle carrying a force, which is the current state, to a flow of information, you know, being these particles being actually flows of information in the field, right?
Yeah.
And so this flow of information organizes the DNA structures, the various minerals, whatever that is, like, so that it produces an effect that's like, you can think of it as a little vortex in space-time, okay? And this little vortex in space-time is carrying information like an antenna, you know, through the system, through like a complex network. Because when people visualize DNA, they tend to visualize what is typically shown, one sequence. But DNA is a very long sequence, right? In almost 3 feet in each cell, right? There's more like this. I used to say that again in my old conference. I had made that calculation. I think it's 5 million times around the Earth, you know, amount of DNA in one person. If I stretch it out, and you know, so it's very complex, and so you can imagine this information flow going through all these little spirals in each nuclei. Does that make sense?
Yeah.
And then imagine that you modify the water structure. Imagine that the level of information flow goes up, right? Then if it does, you're gonna have to have more interaction relationship in the manifestation of all this information flow, right? There's more information flow that needs to flow through. So the DNA might mutate to like a more complex form so it can carry more information. And or you can think of it as the antenna is getting more complex as well. So that would be a more advanced species, maybe, right? You could think of it this way. And you could think of it as an evolutionary path. So the tetrahelix technology is helping the water become more capable of carrying more information, just because of putting it in a certain state of coherency. Not just, you know, so you could eliminate the crystal technology in between. We could just say the electromagnetic field, when it's produced in a certain way, can create a coherent field that influence the water molecule, which in turn influence the DNA structure to become more coherent. So
yeah,
eventually you might be able to get to a point where you can reduce dramatically or even completely eliminate the DNA, well, the RNA and DNA error, transcripting errors, right, that eventually produce more and more decay of the coherency of the body. And you might be able to extend life significantly or even reverse aging.
Right.
Right. So I mean, there's lots of implications. But at a high level of technology, and these are coming, it's just a question of getting there.
Right. Right. Yeah. And so that would just, if you are, as you, I think you said it was making it so it becomes, if the antenna is becoming more complex, then does that improve your ability to, like I had the telepathic question, but I have more questions on this, but I won't go too crazy. But, you know, does that create more complexity in terms of what how you're able to communicate and how you're able to connect in remotely through the field?
If you're thinking about it in terms of complexity, then you might start stressing out. So I'm gonna change the word.
Okay.
The complexity occurs naturally as it's changing, because you're evolving, right? You're actually getting more simple in your understanding. And you're just becoming more coherent. And so you're less of an impedance to the information flow. It's easier for the information to flow through you, so you will have a larger awareness of your environment, of the field around you and all this, so you can become hopefully a little more, you know, harmonious with the environment. Although you will fail at that, guarantee you, a bunch of times. Overall, you know, hopefully you can be more harmonious with your environment. It's not always obvious, you know, with your interaction on planet Earth right now.
Yeah.
But meaning that the information flow that's going through you makes it so that you have a deeper understanding of an interaction with the universe. So I don't think of it as being more complex.
Okay.
It's just, yes, the system is becoming more advanced, more complex. However, your consciousness is just becoming more aware.
Maybe more refined.
And yeah, hopefully more refined in terms of, well, you know, it's a basic refinement of self-sustenance, right? And self-preservation. And yeah, if you look on planet Earth earlier, I used to discuss this with Elizabeth Saturis, which is a evolutionary biologist. Yeah, I remember some of these conversations come all the way back from the, you know, the 90s. But I think, Marshall, you probably were present to some of those conversations.
I was.
Yeah. But you know, microbes went through this. Monocellular systems went through this same type of evolution where they were producing too much pollutant in their environment, which at the time was oxygen. And, you know, they were in trouble, and they almost went extinct because they were in competition with each other. And then eventually they started to collaborate and become multicellular system that could breathe the oxygen, you know, and they became much more complex, and, you know, they evolved. And so basically, it's almost like we're going through the same place, the same, you know, transformation, but at a next level of evolution, where we have to learn to unify to be able to get to this next level of awareness. So each individual, you know, increasing their awareness and connection really makes a huge difference, because each individual that does it increase it for the whole, and in that sense, society becomes more refined, you know, much more refined in its capacity to be sustainable, and its technology, you know.
Yeah, great, beautiful.
Awesome.
All right, Beth, thanks so much for your questions today and always being here. It's good to see you again.
Thank you so much.
All right.
That was awesome. I really appreciate it.
You're welcome.
Both of you.
All right, take good
Thank
take good
you.
care. See you again.
Yeah.
Okay.
All right. There's a couple of questions with 6 votes, and the one that was up there for a while I'll start with first, which is from Thomas Loisel. As an engineer, and after learning about your work and other inventors, I am now bored by standard fields as renewable energy, electric or hydrogen cars. I believe knowledge is limited to hinder human growth, and I don't want to be part of it. Which field should I target? Information physics? So somebody who's ready to jump ship and come over and help out with this whole thing. I'll bring Thomas up, but that's an interesting question. I'm sure there could be many people that are kind of wondering, where do I focus?
Yeah, if you can get him on, that would be great, because I'd love to
bringing him up now.
Exactly, yeah. But because the question is actually, oh, there we go. I'll ask directly. Thomas. Hey, Thomas.
Hey, Nassim. Nice to meet you again. Hi, Marshall.
Hello.
Remind me where you're at, Thomas.
Nice, France.
Ah oui. Alors, on pourrait le faire en français, mais c'est mieux en anglais parce que c'est pour les Anglais aujourd'hui. Mais, yeah, so I was saying I could do it in French, but it's better I do it in English because I think most
Please.
I think it's going to be easier. I may precise my question.
Yeah, because it's a little bit contradictory, but that's normal. It's because you're French. I can say that because I'm too. So it's not one or the other, darling. It really isn't. It's the whole thing. Like the engineering and the electromagnetic experience you have as an engineer is very important. It's a good thing. It's a very, very good thing. I know you're bored of it. That's just because you've done the standard thing. You just got to use it now. You got to use it. You have a very, very powerful tool in your hand. Where did you go to school?
I went to Toulouse, aeronautics.
Aeronautic. Okay, you're perfect. So you're mechanical engineer.
Yeah.
Okay, but the engineering schools in France are excellent. They're excellent. French engineers, it's nice. How many years of physics did you do?
5. Well, it's 5 years of physics.
Yeah, there you go. That's nice. You see, you have physics. Yeah, you will really like this paper. I'm finishing right now. But so your question is good because first of all, if you want to start playing with information physics, we have a little group of engineers and physicists from France that helps us crunch equations voluntarily. So if you want to come and crush equations with us, that's a good thing. So yes, information theory is a really good thing to study if you want to move your studying to something that's not so boring.
Yeah.
And your background in mechanics is going to be really useful because information theory is thermodynamics, and thermodynamics is kinetics, and kinetics is angular momentum and spin and all these things and forces and so on. And so you can actually dive in and really like understand reality at a really, really deep level, right? And you can think of it as studying yourself, right? You're studying matter. You're made out of that stuff. That's the part that scientists forget. They think they're studying an atom over there, you know, but it's the atom that makes them, right? So it's really, you're very, very fortunate to have this amazing tool. Now you can use it for something very powerful, and you can be extremely creative and find new things to explore and so on. So it's wonderful.
Well, that's the thing. I have to find the organization, either private or public, that's gonna let me use this creativity and not gonna say, no, this is not possible. It violates physics, first law of thermodynamics, and no, you can't do this.
All right. Well, you know, that is easy to overcome. Let me help you. You know, that's easy to overcome. You know, that's completely incorrect statement. It's just that comes from bad physics. You know, it is only in the case of a closed system that the statement is true, right? And so far, no closed system has ever been found, especially in, you know, in gravitation or electromagnetics or so on. Like there's always interaction. So, yes, it does not violate any laws of physics. It's just that there's conservation of energy from the vacuum, and the vacuum is omnipotent. You know, it's everywhere. So, you know, the problem is that if you ask the source of angular momentum or the source of inertia, like the angular moment of a planet or a star or a galaxy or a universe, to any physicist, they don't have the answer. You know. So of course, in a closed system, you don't have a source, so it's gonna, you know, it's gonna dampen very quickly. But you know, the source of spin, angular momentum, energy, and so on in the universe is clearly somewhere, right? And you can't just say it's the Big Bang, because then where is the conservation law then, right? What are you conserving that energy from, right? So, okay, so this is easy to overcome. So you just gotta give them the math properly, you know, to show that in an open system you have, you know, equations of states that are very stable, like a proton. You know, that continues to do its thing for trillions of years, you know, so at least billions that we know of. And so this, so yes, you have to find organizations that will support your good science, good physics. And
that's the thing.
Yeah, but as well, you have to be in an organization which can be a mainstream organization, which you can, when you're interacting with them, you have to bring them arguments that cannot be refuted, right? So you have to give them good arguments in terms of mathematics that show, well, you know, it's true, and it's true. Yeah, you know, in a closed system, you're correct. Problem is that there's no such thing in the universe, right? So now that we're from there, right? So, yeah.
You're right. That's the thing.
Yeah. The good news is that we will be at my laboratories needing aerospace engineers very quickly. And so you should send us a resume.
Oh, great.
Yeah.
Sure. Let me send that to you. I'll
Okay.
come. I'll take the first plane. I won't get vaccine though. I'll do something else to be
Right.
able to cross border. But
Try to
Good call.
avoid R&D. Yeah, but I'm not gonna comment on the vaccine thing. But
Yeah, we'll leave that right there. Well, thank you.
Yeah, sorry.
but we are collaborating at a distance with many scientists in France and engineers. So contact Olivier. Contact Olivier Alérol. He's on our web. Send us an email, send us your resume, and we'll go from there.
That's what I was thinking. There are so many engineers in France and throughout Europe that have been meeting and discussing unified physics. That would be great to make a connection to the people that are right there. Well, was it Marc Missian, right? Who was kind of spearheading that for a while.
It was a long time ago. We have a group. So, Mark is still around, but we have a group of people that are crunching equations for us, that are discussing, physics and mechanics, and we have a need for a lot of help in terms of some of the papers, like the paper we're writing right now, because we're scaling across all the different scales, and so you can imagine we have like data sets that have to do both with, like, for instance, data sets on galaxies and clusters and superclusters, but as well on the codata approach to defining the constants and how the algorithm they use to output, a value based on experiment and theory. And so some of these things are unpublished by codata, so it needs to be, recrunched independently. And so we've been doing that because we're outputting from the theory with 12-digit accuracy. We need to know exactly how how much contribution of theory is in these values published by codata and how much is coming from experiment. So,
all right, thank you so much.
Yes.
Thank you.
Want to leave it there? Okay.
Yes.
Wonderful.
Nice
Thanks for that great question.
Nice to see you again. Bye-bye.
Good to see you. Many people really appreciated that conversation. It's very helpful.
That's great. France has such an amazing scientific culture. It's really great, and the new generation of engineers and physicists that are coming out are really excited about improving on what they've been taught. Let's just put it that way. And and that's nice to see, and it's really powerful what is emerging from the new generation of engineer and physicists. It really is encouraging to see it from that perspective, like to see the new generation, like, getting that there is a really big need to, like, do things a little bit differently and find solutions. And
really encouraging that that's happening. For sure.
Yeah, for sure.
That's like the leading edge of the shift that we were talking about at the beginning, right there. Bringing that consciousness, that awareness, that dedication and focus into actually changing it in all fields.
Yeah,
critical to happening.
I can understand how you can get bored and feel like, where do I go?
Yeah, totally. I
because
felt
if
that way when I was, 40 years ago in school. So,
yeah, so
I'm sure you did too.
but well, yeah, for me it was a different path, but
Yeah, of course,
yeah,
of course.
I was never bored, in 30 years from studying physics because I did it the way I wanted to, and I did by passion.
Yeah.
But I can see that if you're working in an organization where it's very difficult to bring new ideas in, that would be difficult and frustrating, and that's why I became an independent.
Definitely. Yeah. Well, let's see if we can get 2 or 3 more questions in before we complete for the day.
Yeah.
Christiana was asking about the global geometry of sacred sites and temples, which I know you've talked about a number of times
Yeah.
in calls. Do you want to touch into that today, or?
Let's do another one.
There's a physics question here from Oriana. Do you want to go for some full-on antimatter discussion?
Sure.
Could you please speak to the role of antimatter in the holographic universe model? That's definitely a question I'm curious about, understanding the role of antimatter.
Okay. So you can think of space as a fluid, right? Planck fluid. And you can think of it as being like having an angular momentum, meaning that it's rotating in a certain way. And as it rotates in a certain way, hi.
Hi, Nassim.
Oriana,
Correct.
All right.
Good to see
where are you at?
I am in Tucson, Arizona.
Oh, right on. Nice rainbow.
Isn't it? Out of my backyard, actually.
Yeah, wonderful.
All right.
Yeah. So, yeah. So imagine that you have a field that's rotating, right? So imagine fluid dynamics, right? When they're occurring, they produce flow and counterflow, right? So this direction of spin of the flow would determine like matter and antimatter. And you can imagine that if two flow collided in the right way, they would cancel each other out, and they would emit its energy, right? Like the rest of the water would conserve the energy, and so it would emit, and it would cancel each other out. And so that is matter antimatter interaction, right? There's a gamma ray emission as a result, and they call it matter antimatter alienation, right? And so basically, the fact that we've called it antimatter is coming from a perspective of being in a spin that's in a certain way, right? And coming from that perspective, then the other one seems anti. But it's not necessarily the case. For instance, if you lived in an antimatter universe, you would think of our matter as antimatter, right? Or, and so it has to do with from which part of the universe you're coming from. So that means that region of space, like the whole universe we're in, would have regions of matter and regions of antimatter, if you'd like, for which we see, for instance, in our galaxy. Like, for instance, the jets of our galaxy are antimatter jets. These big jets are coming out of the black hole, right? So we have good telemetry of the one, on one side of our Milky Way galaxy, of this antimatter jet. So you can think of it as, maybe we're in the universe if you think of the universe split in two torides, we're in the one toride that we call matter, and stuff that's flying around that's going the other way from the lower toride is what we call antimatter.
Okay, that's actually what I was curious about, is the torus and into a double torus, but also what I had looked at for the universe, anti-universe, is the anti-universe is considered an opposite charge, but is it an opposite spin or just an opposite charge? Because they were saying everything else is the same except the charge. So it didn't quite make sense. But it is an opposite spin?
Yes, correct. Yeah, it is an opposite spin. That's when we see antimatter in cloud chambers, we see it spinning the other way, right? So, yeah, it is an anti-spin.
Okay.
But the concept of opposite spin is depending on the frame of reference from which you observe it, right?
If you have a torus, torus appears to, at least at one example, come in from the top and out at the bottom, and a double torus comes in and out at the equator. Now, is there a spin opposite then to go out at the equator and down towards the bottom?
Yes, I asked that question, and it's a hard question to answer because it's more complex than this. So think of it as, okay, water going down the drain in your tub, okay, in your bath. That means there's air coming out, right? So the water is coming in, there's air coming out. When the air coming out is going opposite, then is spinning opposite than the water going in, right? So that, the relationship of the torides is more that, like, for every spin there's a counter spin. You could even think of it as if there's a wheel spinning between you and I'm gonna swear it's going one way, you're gonna swear it's going the other way, right? So who's correct? Like, between your statement and my statement, the wheel is not spinning at all. So you see, so the relationship of the spins have as well to do with the relationship of the frame of reference, and that's why there's complexity in relativity. But one thing that you can think of is that there's opposite spins, meaning that for every spin, there's an opposite spin, right? So yeah, go ahead.
Well, no, that's kind of how I began to think of it, rather than matter, antimatter is matter, anti-spin. But I couldn't find any other reference to it being
not anti-spin, but counterspin.
Counterspin.
Right. So because anti-spin would be like saying anti-light. You can't. It's not anti-spin. It's like it's not anti-gravity. It's gravity control, right?
So in looking at evolution and encoded information that compresses that information in so that one cell goes to a multi-celled being in all evolution in 9 months, that encoded information would be a spin in as it's spinning out simultaneously.
Yeah, you can think of, like, the thermodynamic effect of this compression of information. is like the spinning out part, right? There's radiation, there's like contraction and expansion at the same time, right? They're not.
It's all
So
the
the,
same movement.
yeah. So the torides
Always.
are spinning in opposite direction, but then they're going through each other, right? Re-expanding on the other side. So if you look at one of the mouth of the toride at the top of the double torus, you would see, you know, you stop spinning this way and then stop spinning the other way coming out, you know, and, you know, so they're within each other, if you'd like, you know.
Right. Okay, so that's what I discovered in this point of most influence. I was looking at the where evolution actually encodes, and there's a moment where the fractal pattern is, depending on which way you look at it, the spin looks one way expressing out and the other way compressing in, but it's all the same movement.
Correct.
That,
You know, it's like the arm of a galaxy spinning out.
mhm.
If you think of the, I saw a nice video you can find on YouTube, maybe. You know, you have a flow of water and you put a rock in it. In this case, it's not a rock, but it's a barrier that they constructed in there. Okay. And it's producing like eddies behind it. Okay. Spin count. And the eddies that it produce, the disturbance it produce, in there, if you get the right place, if you place a dead fish, okay, like that just died, it will swim up the current to the obstacle, right, against the current. It will swim up, and it doesn't look like it's dead. Like if you look at it swim, it looks like it's fully alive. They swim exactly that way. I mean, these animals are made to be most efficient, right, that way. So this because of this spin counterspin, you always have the two relationship, and the two relationship produce, you know, movement and this movement is what we call subatomic particles orbiting, creating an atom, or an atom orbiting in the solar system, or a solar system orbiting in a galaxy, or, you know, these spiral relationships. And then you were talking about, like, you can think of like on the surface of a planet, like that there would be these spiraling relationships as well between the interaction on the surface, right? You can think of it energetically in terms of thermodynamics, or, you know, like you'd have these vortices, like you can think of hurricanes, you know, storm systems, electromagnetic discharges like lightning and all this stuff, like all kinds of, you can think of tornadoes. Well, you can think of a human being as one of those vortices, okay, which is like in the field of space-time, meaning that it, you know, it's not as obvious of a vortice as a tornado, but it's a kind of vortices of energy that's organizing matter in a certain way.
And at what point does it become a torus from a vortex?
Oh, it's the torus and the vortex and the torus is always one inside each other. It's always a dynamic flow. Yeah, it's
the only way a vortex is created is because of a torus, right, Nassim?
Right.
A vortex.
So a tornado would be like a rainbow. You only see half of it, but it's actually a bubble.
Oh yeah. If you look at the way the air in the tornado is circulating, it's very much a torus. Exactly. If you look at the way the air is circulating in a hurricane, it's very much a torus, you know, and so on. Yeah.
A vortex in a whirlpool in water, same thing underneath the surface is
So at
toroidal.
what point does a
flow.
torus become a double torus?
So when you have spin, counterspin.
There's my antimatter. Oh my gosh.
There we
Okay.
go. Well, let's leave it at that one. I think we're gonna
Bring us full circle. Thank you.
It's just gone full circle.
We only see half the
It's just gone
rainbow.
double
but-
toroidal.
Yeah. So for instance, yeah. And so if this is true, and this is, I mean, this is the thinking I was having in the 2000s, you know, when I was still in my van, was if this is true, then eventually we should see like high energy physics happening in the center of tornadoes and hurricanes. And so then I went on. At the time there was no internet, so I went on, you know, in universities, like searching for evidence of high energy physics in tornadoes and hurricanes. And at the time, you know, the sprites were not measured. So, you know, I was looking at tornadoes and finding all kinds of anomalies about the energy levels in the center of tornadoes and the effects it was having on objects, where objects were found to like go into almost plasmified and then come back, you know, and so on and things like that. But that was mostly anecdotal, and there was some photographic evidence, but it was hard to find. But then we launched satellites to try to measure gamma ray emission that we were seeing in astrophysics. They were called gamma ray bursts that we were seeing everywhere in the galaxy. There was these bursts of gamma rays. We were trying to figure out where they came from. So we launched satellites to look for the source of the gamma rays. So those were a specialty satellite that were turning towards a source of gamma ray as soon as it would pick it up and start taking telemetry in that region to try to figure out what's going on over there. That was doing that. And when they were first launched, some of them turned towards the Earth and started taking pictures of hurricanes. And then it was found that antimatter matter collisions were occurring in the center of hurricanes in the form of jets that emerged from the heart of hurricanes. There's actually amazing pictures that were taken on Mauna Kea in Hawaii just a few weeks ago that was published because the clouds were below the volcano, so they could take pictures of this amazing jet of antimatter that's being produced in the center of hurricanes, right? So this is the counterspin, right?
So is there singularity then inside of the vortex that would create the dynamic of the double torus?
Yeah, you can imagine the storm being at the equator of the double torus, and then the jets, you know, on both sides, and the double torus thing, you know. So you see it there. That was really confirming for me. It is confirming as well that you can, you know, first of all, there's nothing in current physics that explain how antimatter can be, you know, those are high energy physics that are occurring in the middle of you know, the eye of a hurricane. You know, it's unexpected. Eventually, we figure out that the gamma ray bursts, I should finish the story, that the gamma ray bursts that we were, you know, measuring are from supernova explosions that are occurring everywhere in the, you know, in the galaxies and so on. So but where we get gamma ray emission from hurricanes here on Earth as well. So it really is remarkable, but you can start to visualize all these dynamics more clearly because they're occurring at all the scales. And that's why there's you know, that's why there's an electron and a positron, and you know, that's why Dirac's equation eventually found out that, yeah, E equals mc squared is true, but so is minus C equals mc squared, right? Which led to the discovery of the positron and so on, right?
Right. Great. All right.
Go with the dynamic
Let's leave
balance.
it there for today.
Thank you.
Always. Ariana, thanks for always for being here with us. Good to see you.
Thank you.
Take good care. Nassim, we're a little past our hour-and-a-half mark. You want to leave it there for today?
We could
leave it there for today. Or?
Yeah, just one more maybe.
Yeah. Okay. You know, there's one that I think is very interesting in its relationship to fundamental theory as well as your paper you're working on, which you want. I'll read it to you. You can see if it is one you'd like to do. It's from Michel, I would presume the pronunciation is, saying, "Hi Nassim, could you briefly ponder on how your unified physics model ties into the hierarchy of levels in David Bohm's physics? That is the implicate order that informs and directs the explicate order, and then the super implicate order that informs the implicate order, et cetera, to infinity in both directions."
Well, that's a straightforward, you know, that's a direct relationship to the physics I've written. This is why Bohm,
that's what I was thinking.
Was very much, yeah, Bohm was very much on it. He was right there. And if it wouldn't have been from all the opposition he received, I think we would have got there a long time ago.
Yeah.
You know, mostly from Eisenhower.
Was that right? With the whole Communist Party thing back in the.
It was. It's a good question. The implicate and explicate order is that feedback of information between, you know, the system and its environment, right? And so it is the information flowing out and the information flowing in, which you can define directly in terms of electromagnetic radiation and gravitational compression, right, of the information, which produce mass. And I've solved these equations now in this new paper, so I'm very excited. So he was right on it, and then the fact that it's happening at different fractals, like it's fractal, it's like that all the way down and all the way up, right? So it's an information exchange all the way down to the Planck and all the way up to the universe. And that's just that. Then there's the sub-Planck and the multiverse, you know, and so on. So it's infinite in all directions. Bohm had figured that out. And he was on his way to unifying physics with it. He didn't get the support he needed to get it done. It's kind of sad. But, you know, he knew that the vacuum structure was the key to understanding these dynamics. He was talking to people, telling them, you know, other astrophysicists and so on, telling them what we need to study is what's between the stars, you know. We have to think of the night sky as full of energy with little points of light in it, right? So that emerged from that energy. So, I mean, I'm paraphrasing, but in general, he was thinking that way, knew about it, and he definitely was on it. It was remarkable. It was remarkable, and it really had a very um, uh, great opportunity because it was inside the institution to really make a change and be an opportunity. And at the time, you know, there was other interests. We'll just call it like that. That had to do with the state of affair of political relationships on the planet that stopped that effort. And that's why I was saying earlier, the first step is to unify, you know, all of our cultures, all of our differences, realize we're all one thing flying through space on a pretty peculiar spaceship, you know, it's a good one. And, you know, it's got a very specific lifetime cycle, and so yeah.
Okay, well, thank you so much, Nassim. I was just thinking, did you ever meet David Bohm, or were you still a bit too young at that time?
Yeah,
I think he died in the 80s, right? Late 80s.
He didn't die that late. Yeah, and so was somebody I would really wanted to. I caught a few, you know, I caught a few good ones. Another one I really wanted to meet that I never got to meet was John Wheeler. That would have been great to spend some time with Wheeler. Bohm, of course, many others. At the time, I didn't have what I needed to have the conversation that I would have today. So
right.
However, most of the concepts were there. And at the time, I did realize that Bohm had come very, very close and was on the right path. So was Wheeler. But at the end of his life, Wheeler explored some of these ideas, and like usual, the field said, well, he's old, and so he's talking about, you know, so you know, it's been the case for a while. Same thing with Dirac. When Dirac talked about the large number hypothesis, it was discarded as numerology from one of the best mathematical physicists on the planet, you know, that solves some of the hardest problems in physics, like quantum field theory, which is, you know, and did a pretty good job at unifying, you know, relativity with quantum theory as a result, at least the first step. And so there's been a lot of pieces that have been floating, right? Like the one thing that Dirac contributed out of his equations that were accepted, that were not deemed numerology, was quantum field theory, which is the Dirac sea with the particles, the Planck particles that emerge, you know, that are fluctuating at the Planck scale and so on. I mean, all these pieces have been there, you know, they just hadn't been put together before. Viewed from my perspective, it was obvious, oh yeah, you know, that goes with this goes with that. However, the mathematical formalism to be able to express these relationships took me 30 years, you know. So, you know, I'm finally finishing it, and it's in that next paper. Yeah.
That's awesome.
Yeah.
All right, great.
Okay.
Thank you,
Well, nice
Michelle.
to meet you. Where were you from?
I'm from the Netherlands actually, but I did live a few years on Oahu in Hawaii. So I'm sorry that I never was able to meet you there on the Big Island. But I'm back in Holland right now.
Oh wow!
Yeah.
Awesome.
So, actually, I have another question, which is well, related and unrelated. In November, I sent you an email, and I just used all the email addresses that I could find on your papers, because I studied your quantum gravity holographic mass paper for months and months. I'm not a physicist. I'm a biologist, but I like math. So I think I found a few typos in some equations. So I sent you an email asking, are these typos? And I think it may be useful to you, but I'm not sure if you've seen the email.
I know of one typo on the gravitational coupling constant equation. So that might be the one you found, or yeah, I gotta look. Just send it to us. I'll look for it. Which address did you use?
Yeah, it's Mick Schotten, MICSCHOTTEN @hotmail.com, and I sent it on November 20 of last year. But I found a few typos.
I don't know what that address is.
Okay.
Is there a way to reach you, or send it again, or?
Yeah. Send it to. I think it's if you go on our Taurus Tech website and send it to Taurus Tech, then it will get to me. I'll make sure we look for it.
Okay, I will do that. I'll do it right tonight.
Yeah, TaurusTech.com. TORUSTCH.com.
Okay, I will do that.
Yeah. Thank you. I appreciate.
Thank you so much for everything you do, and I can't wait to see your new paper, like so many people. So
yeah,
that's for sure.
I know it's taking a long time, but it's gonna be good. So, and it's so big and overarching. It's just taking a long time.
Yeah, I can imagine.
All right.
But, good luck with that.
Thank you. I appreciate it.
Thank you so much. Take care.
Thank you. Bye-bye.
Bye-bye. Okay.
I want to close with one. Funny story I just heard about a friend who back in the 90s was in London, and he was actually involved with psychedelic research back in with Timothy Leary and Richard Alpert. So he's really had a long history of deep inquiry into consciousness and the science. And he was in London back in the 90s, and he knew Bohm was living there. So he thought, well, maybe I can call him up and go interview him. So he did. He called him up. Bohm said, sure, come by, come by today. And so he's like, quite nervous. And some friends of his had given him some hashish. And so he thought, well, I'm so nervous, I'm so anxious, I'm just going to have a little hashish. And he took a few hits of it. No. And he got so stoned. He said, here I was just the smartest man in the world, and I was the most stoned man in the world. Can you imagine?
Oh, no. Probably.
I love that story. That is a great story. One of those classic cosmic joke moments,
Yeah, for sure. For sure.
But I'm sure he had a great conversation nonetheless.
Yeah, I'm sure.
So fascinating.
Yeah. Yeah, both amazing.
All right. Yeah, truly so. Yeah, thankfully there are so many great videos of him discussing his ideas, his theories, and relationship to understanding that Krishnamurti and Dalai Lama and everybody, all they were saying. And boy, yeah, he was so tuned in.
Yeah,
well, Nassim, that was a great day. Thank you so much again.
Thank you.
Appreciate it.
It's great
Yeah,
to be
welcome.
here.
Thank you, everybody.
Those were excellent questions. It's fun to interact with the world. I'm a little bit in my cave. We're going caving again next week, you know, to try to advance faster on the paper. So I will be out of touch.
Okay, good. Well, we're always connected, but we'll be out of touch.
Yes. Exactly.
Okay, well,
it's
we got a whole community of people rooting for you.
Thank you.
What's that?
It's the infinite boundary thing, you know.
That's right.
Yeah.
That's right.
It's the appearance of isolation.
Well, everybody here that's listening, just tune in, you know, get into your own coherent state and just beam that coherence into Nassim's cave. And that's how we can help the process now.
Yeah.
All right, everybody. Thank you for being here again. May the Mac be with you.
Yeah.
Take care, everybody. Bye-bye.
Thank you
See
so
you next
much.
time.